Let me paint you a picture. You're building an e-commerce application. Early on, everything's simple. You've got an inventory service, a payment service, maybe a shipping service. Your client code, it calls each one directly. Fine. But here's what happens as systems grow. You've also got an invoice service, a notification service, an email service. And now your client code looks like this tangled mess. It has to know about every single service, call them in the right order, handle their individual failures, and orchestrate the whole flow itself. Three things happen when you do this. First, too many subsystem dependencies. Your client is tightly coupled to the internals. Second, complex orchestration logic ends up in client code. Clients shouldn't be thinking about first check inventory, then process payment, then create shipment. That's business logic. Third, debugging becomes a nightmare. Direct access to too many services creates chaos over time. So what's the solution? The facade pattern says, expose one clean interface that hides the internal complexity. Instead of clients talking to 6 services, they talk to one, the facade. And the facade handles everything behind the scenes. It simplifies interactions with complex systems. Your client code goes from 6 service calls to 1 method call. That's not a convenience. That's a design principle. It reduces client-side dependencies, and it improves maintainability and readability. One clean entry point can dramatically reduce architectural complexity. Let me give you the textbook definition and then break it down. The facade pattern provides a simplified, unified interface to a group of complex subsystems. That's it. Instead of handling multiple integrations directly, clients interact with one centralized layer. The diagram on this slide shows it perfectly. Facade sits on top, and below it are the subsystems. The facade is the only door into that system. Key points to burn into memory. It hides subsystem complexity. It exposes simplified APIs. It improves developer experience. Now let's make this real. Think about an e-commerce checkout flow. When a customer clicks Place Order, what actually has to happen? The system needs to check inventory. Are the items even available? Then it needs to reserve those items so no one else buys them. Then it processes the payment. Then it creates a shipment and arranges delivery. Then it generates an invoice. Then it sends a confirmation email to the customer. That's 5 to 6 subsystem operations for one customer action. Without Facade, your checkout controller is calling all of this directly. It knows about each and every services. That's 5 imports, 5 potential failure points, 5 things to update when any service changes. With Facade, look at the architecture diagram. The client makes one simple method call. The Facade receives that call and internally orchestrates all 5 subsystems. Then it returns the result, order completed. The client interacts with only the Facade. Facade handles the complexity. This is not just elegant. This is how professional systems are built. Let's get into the code. 3 steps. Step 1. Create your subsystem services. These are the classes that contain the actual business logic. Notice these classes don't know about each other. They don't know about any facade. They just do their own job. That's correct design. Subsystem contains the actual business functionality. Step 2. Create the facade class. This is where the magic happens. Look at what order facade is doing. It holds private references to payment service, inventory service, and email service. The client never touches those directly. And place order, that single public method, is the entire interface. It coordinates the sequence, reserve inventory, process payment, send email, in the right order every time. Step 3. Use the facade from your client code. That's it. 2 lines. And the output? Inventory reserved, payment processed, confirmation email sent. 3 subsystem operations, 1 method call, 0 complexity exposed to the client. The client interacts with one simplified interface. This is what Facade is. This is what Facade does. And if you've ever worked in a service layer in .NET, you've probably used this pattern without knowing it had a name. All right, interview time. These are the questions you'll actually get asked. What problem does the facade pattern solve? What's the difference between facade and adapter? Can facade become an anti-pattern? Where is facade used in .NET? Pause here and review the answers. Let's bring it all together. Facade pattern helps architects build systems that are easier to use, maintain, and scale. It creates clean interfaces while hiding orchestration complexity internally. 4 things to lock in. Simplifies large systems, one interface, multiple subsystems underneath. reduces coupling, clients don't depend on subsystem details, improves maintainability, change a subsystem, update the facade, clients are untouched, creates better developer experience, readable, intuitive entry points into complex functionality. And the closing thought from the slide: great design hides unnecessary complexity behind elegant interfaces. That's what Facade is. That's what great architecture is. All right, that wraps up day 9 of the 23 Design Patterns Simplified series. If you've been following along, you've now covered 9 patterns. You're building real pattern fluency, not just surface-level awareness. That matters in interviews. That matters when you're designing systems at scale. Day 10 is coming, and we're diving into the Flyweight design pattern. You'll want that one if you've ever dealt with memory-intensive systems or large object creation. It's a performance powerhouse. So here's what I need from you right now. If this helped you, smash that like button. It tells YouTube this content is worth showing to more developers, and honestly, it takes you 2 seconds and it means a lot. Subscribe if you haven't already. We're dropping one pattern every single day. Miss a day, miss a pattern. Drop a comment below. Tell me, have you used the facade pattern in your own projects? Where? What subsystems were you hiding? I read every single comment. And share this with a developer friend who's preparing for interviews or building complex .NET systems. You might just save them from building a god facade disaster. Follow me on Instagram at @fundamentallyclear for architecture tips, short-form breakdowns, and behind-the-scenes content. I'll see you in day 10. Keep building, keep learning, stay fundamentally clear.